Hello dear students, my name is Dr. Vaishali ghai and the name of this channel is Tricks by Chemistry Guru. And in the series of quick revision for class 9th physics chapter motion, today we'll discuss about the graphical representation of motion. In the previous topic or video I've uploaded about the acceleration, uniform and non-uniform acceleration. I've explained when its value is positive and when its value is negative, that we have discussed in the previous video. Now today we'll talk about the graphical representation of motion. So first we'll talk about the distance time graph. So all these are distance time graph. First is this A graph is the distance when the body is at rest. So in this case, that means there is no change in the position of an object and body remains with increase in time, with change in time. So the distance time graph when the body is at rest is a straight line which is parallel to time axis, and I can say there is no change in the position of that object. Object is at rest. Second we have is the distance time graph for uniform motion. So when we talk about distance time graph for uniform, we say that uniform motion means when object covers a uniform equal interval of time, we can say that motion is uniform motion. And we get a straight line graph which is inclined at a constant angle from this time axis. So we get a constant angle. Okay. So this angle will remain same throughout. So I can say it is a straight line with a constant angle inclined from the time axis. When we talk about this object, uniform motion means it covers equal distance in equal interval of time. If we want to find the speed at this point of an object, I can find as distance traveled by the object divided by time taken. What time it has consumed or it took to move from point A to point B. So this is basically a uniform motion, and we can find the uniform speed by using this graph. So uniform speed, let me write it as V, it is distance traveled. So if suppose initially an object was at A and finally it reaches to B, that means the distance traveled by this object is d2 minus d1. So I can write distance traveled as d2 minus d1 is equal divided by what time it has taken. Initially it starts at t1 point and finally it reaches at t2 point. So time taken is t2 minus t1. So if I know these values, d2 minus d1 divided by t2 minus t1, I can get the value of speed. Right? Now we have next two graph, distance time graph for non-uniform motion. Non-uniform motion means when an object travel unequal distance in equal interval of time, we call it as non-uniform motion. In this case, we can find the slope of distance time graph as the ratio of these two. Okay, but here non-uniform motion says that the distance time graph shows a non-uniform variation in both the cases. It means an object covers unequal distance in equal interval of time. Now we'll discuss about the velocity time graph. So we have two velocity time graph. One is for a uniform motion. This A graph is when object is showing uniform motion, and another is the velocity time graph for uniformly accelerated motion. So we'll discuss these two. Now when we talk about a uniform motion and we get a velocity time graph as a straight line which is parallel to this time axis, it says that when an object starts with a constant velocity, constant means uniform velocity, it does not change, only the time goes on increasing. So velocity remains same. An object starts at this point with the same and uniform velocity, reaches at this point B. Okay, now how we can calculate the displacement using this graph? How we can calculate the displacement? So displacement from this velocity time graph can be easily measured or determined by the area enclosed in this region. So whatever be the area we'll be having in this region, we can calculate displacement. So displacement basically is the area enclosed by velocity time graph. So if I talk about this point, object starts from point A to point B with constant velocity. So just make these two lines and cover this area. This area gives us the displacement. Okay, the magnitude of this displacement can be determined by the area enclosed by velocity time graph. So we can find this is if suppose it comes out to be rectangular, which is actually in this case. So we can find the area of rectangle and we can easily measure the length and the breadth for this graph, and that gives us the value of length into breadth, gives us the value of displacement. Now when we talk about uniform accelerated motion, we get an inclined straight line that is passing through the origin. We get this inclined straight line that is passing through the object. It shows that we have a uniform accelerated motion. That means a continuous change or equal change in the velocity with equal interval of time, in equal interval of time. So now using this uniformly accelerated motion graph, we can find two things. One is acceleration, and acceleration is basically, we know the formula of acceleration as change in velocity divided by change in time. Change in velocity divided by change in time. So here the velocity is, say this is the velocity, that is v1, and this is the velocity as v2. So v2 minus v1 gives us the change in velocity. I can write here v2 minus v1 divided by, say it is at t1, this is t1 time when the object is at A position, and t2 when object is at B position. So change in time is again t2 minus t1. So this ratio, I can say, if this is, let me write it as A, B, C, D, E, F. Okay, so this distance, what is this distance? If we talk about this distance, G. So BG, this is BG divided by AG. Okay, that is V2 minus V1 divided by T2 minus T1. So this comes out to be BG divided by AG, and this is the slope that gives the value of acceleration. So from velocity time graph in a uniformly accelerated motion where we are having this inclined angle, inclined straight line, then this ratio is the slope, and that slopes gives us the value of acceleration. So now you can find the acceleration from this graph very easily. One more thing is, if I say you to find the value of displacement, the magnitude of displacement. Displacement means it starts from this point, okay, and with a uniform or constant velocity it moves to this point. So whatever be the area enclosed, आप यहाँ से यहाँ तक का जो पूरा एरिया है, जो इस एरिया को आप लेंगे, that area enclosed in this shape, we get the magnitude of displacement. Now how to get the area of this? Let us write this is ADCB. Okay, this ADCB. So this is basically the area of ADCB. Now this is either trapezium, you can find that area of trapezium, or you can consider one as the area of this rectangle plus area of triangle. That also you can find. So the displacement now can be calculated as area of rectangle. What is this rectangle? ADCG. Okay, this area of rectangle is ADCG plus area of triangle, that is AGB. Area of triangle AGB. तो आप इस एरिया को ऐड कर लें and you will get. What is area of rectangle this? So this is AD into DC. I can write AD into DC is area of rectangle plus what is area of triangle? We know that half into base into height. So half This is base into AG into height is BG. So putting these values, we can easily find the displacement value using this graph. So using graphs, we can calculate the acceleration and the magnitude of displacement if we have uniformly accelerated motion. So these are some graphs. Based on these graphs, we can find various calculated quantities. And in next video, we'll discuss about the equation of motion and all these three equations of motion by graphical method. So if you like this video, please give a like sign and subscribe my channel. Thank you. All the best for your exams.